Okay, here is today's lesson 5-6, the equation of a circle. Now, the equation of a circle with radius r and center hk is expressed by the equation x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. The key in this formula is right here, that these are minuses. So this equation would be represented by this picture, where I have a radius of some length and a center at hk. I'm going to come back to those being minuses in a minute. So let's look at a nice easy example. Write an equation for the circle with radius of 4 centered at the origin. The origin is at 0, 0, so that is my hk. My radius is 4, so that means r equals 4. If I think about that general equation, x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. And I just substitute in my values for here, here, and here. I get x minus 0, the quantity squared, plus y minus 0, the quantity squared, is equal to 4 squared. Clean it up. X squared plus y squared equals 16. And that is the equation of that circle. Now, if we look at another example of radius 5 centered at 1, negative 8, and I think about my generic equation, this is on your reference sheet. Now, my h is 1, my k is negative 8, and r is 5. So I have x minus 1, the quantity squared, plus y minus 8, the quantity squared, is equal to 5 squared. That y minus 8, the first minus is for the formula. The second minus is because the point is actually negative. Clean it up. X minus 1, the quantity squared, plus y plus 8, the quantity squared, is equal to 25. That expresses all of the points for that whole circle. Now, sometimes we have the picture and we need to write the equation. So hk is given to us right here, so that's nice, but there doesn't seem to be a radius. But if I look at the center to any point on the circle, that's really the radius. And if I need the length or the distance between two formulas, or 2 points, I'm going to use the distance formula. So the radius is equal to the square root of 4 minus 2, the quantity squared, plus 8 minus 4, the quantity squared, which is equal to the square root of 2 squared plus 4 squared, which is equal to the square root of 4 plus 16, which equals the square root of 20. Now I'm going to leave my radius as the square root of 20 for right now. I'm going to go back to my generic formula, x minus h, the quantity squared, plus y minus k, quantity squared, equal to r squared. And I'm going to substitute in for each of my values. So I'm going to have x minus 2, the quantity squared, plus y minus 4, quantity squared, is equal to the square root of 20 squared. That's why I didn't change that square root of 20 to a decimal. Clean this up, nothing changes here. What's the square root of something squared? They cancel, and so my radius is 20. Now, the next type of problem that we can do is given an equation, graph it. So if this is my equation up here, and I think about x minus h, the quantity squared, plus y minus k, quantity squared, equaling to r squared, this plus 6 doesn't seem to fit my formula. So what if I rewrote this as minus a minus 6? That still fits my formula because now the minus makes it very clear that my h is negative 6. There doesn't appear to be anything being added to the y squared, so that makes the k 0. So hk, my center, is at negative 6, 0. Now if r squared is equal to 25, then r is 5. So now I can graph it. Negative 6, 0 is right here. The radius extends out 5 in every direction from the circle. So let's pick some easy radii. 1, 2, 3, 4, 5. There's a point on the circle. 1, 2, 3, 4, 5. There's a point on the circle. 3, 4, 5. There's a point. And 1, 2, 3, 4, 5. There's a point. So this is my circle with radius 5. Now write the equation of a circle whose diameter's endpoints are at 1, 4, and negative 3, negative 2. Let's just sketch a picture so that we know what we're doing. If I have negative 3, negative 2, and 1, 4 as the endpoints of a diameter, I'm looking at something like that. Now I could graph it exactly, but we know that things don't always line up perfectly. So the easiest way to find the length of the diameter would be to do the distance formula. So the diameter is equal to the square root of negative 3 minus 1, the quantity squared, plus negative 2 minus 4, the quantity squared, which is equal to the square root of negative 4 squared plus negative 6 squared, square root of 16 plus 36, which equals the square root of 52. Now remember, that is the length of the diameter. All right, 52. So the square root of 52 is approximately 7.2. Now from that, I'm going to get my radius is equal to 7.2 divided by 2, which is 3.6. Now I need a center. Now the center of my radius looks like it's in the middle, and I have a formula that would let me find the midpoint, which is the middle of that segment. So if I use the midpoint formula on this diameter, I'll find the center of my circle. So the midpoint formula is, so hk will be equal to negative 3 plus 1 divided by 2, negative 2 plus 4 divided by 2. So hk is negative 2 over 2 and positive 2 over 2, which makes it negative 1, 1. So the equation of my circle is x minus minus 1 quantity squared plus y minus 1 quantity squared equal to 3.6 squared. Clean it up. X plus 1, the quantity squared, plus y minus 1, the quantity squared, is equal to 12.96. Now, given the circle, equation of a circle, sometimes we want to know where points are in relation to our circle. So if we just think about this for a minute, if this is our circle, this circle right here has center at 1, negative 1, and it has a radius of 4. If you look at the first part of this formula, it looks a whole lot like our distance formula. And if you think about things, if a point is on the circle, then it's going to make that equation true, which means the left side here will equal 16 when you substitute x and y in. If I have a point that is outside of the circle, that distance from center to that point is going to be greater than whatever my radius squared is. And if I would happen to have a point that would fall inside the circle, that distance from that point to the center is going to be less than whatever the radius squared is in our formula. And so these problems end up being very simple. We substitute our x and our y in, and we compare it to our radius squared. So we are going to have 2 minus 1, the quantity squared, plus 4 plus 1, the quantity squared. And we want to know how that compares to 16. Is it greater than, less than, or equal to? So I have 1 squared plus 5 squared. How does that compare to 16? I have 26 compared to 16. And of course, 26 is greater. Therefore, my point is outside my circle. And I just repeat that process with my other 2 points. So if I substitute 2, 2 as my x, y in, and I have 2 minus 2, the quantity squared, plus 2 plus 1, the quantity squared, how does that compare to 16 using my original equation? Well, 0 squared plus 3 squared. How does that compare to 16? 9 compared to 16. Clearly, that is less than. Therefore, my point is inside my circle. And our last example, if I have 1 minus 1, the quantity squared, plus 3 plus 1, the quantity squared, how does that compare to 16? 0 squared plus 4 squared compared to 16. And that, as you would expect, is equal. Therefore, my point is on my circle. That is the bulk of the circle lesson. Part 2 will cover the completing the square.